So 12th standard physics volume 2 unit 6 ray and optics book by question we are seeing. So in this way we are going to see the 10th question. Okay, a ray of light traveling in a transparent medium of refractive index n falls on a surface separating the medium from air at an angle of incidence of 45 degree. The ray can undergo total internal reflection for the following n, right? So there what they are telling is a ray of light traveling in a transparent medium of refractive index. Okay, the light traveling in the transparent medium of refractive index n, okay, falls on a surface separating the medium from air at an angle of incidence 45 degree. Okay, second message, the ray can undergo total internal reflection for the following n. So which refractive index of the following medium can be a total which makes a total internal reflection? Okay, that is the question. So book page number 19. Okay, so 19 there's something, the message is given. So before that the image will be clear in the 20th page. Okay, just see the 20th page, the total internal reflection. The condition is total internal reflection. So the medium is, one is air, another one is another medium, right? It may be water, it may be some other liquids. Okay, so what they are saying, a ray of light traveling in a transparent medium. Okay, this one is a transparent medium traveling of refractive index is n. This medium refractive index is n on a surface separating medium, on a surface separating a medium from air. Okay, from air, this is air medium, this is something transparent medium. Okay, on a separating the medium from air at an angle 45 degree of incidence. So this is what 45 degree. The ray from here fall on that medium surface at 45 degree. The ray can undergo total internal reflection for the following. So which is the n of the material? Okay, that's our question. Okay, this diagram represents the total internal reflection. So we know the page number 14, the Snell's law, sin I by sin r equal to n2 by n1. Okay. So now page number 19, just see that from that Snell's law, n1 is sin IC equal to n2 sin 80 degree, sin 80 degree is 1. So we know that equation explanation. Okay, for explanation we just see what it actually comes. Okay, sin IC is equal to n2 divided by n1. So here n1 is greater than n2. So what is n1? n1 is refractive index of the material, medium. Okay, n2 is the air medium. This means the refractive index of the medium is greater than the air medium. Okay, that is what. This is air medium is less than of this medium. So if an air medium is air, then its refractive index is no, don't worry about. So this is what the sin IC they are given. Sin IC equal to sin 1 by n, or IC equal to sin 1 of 1 by n. So the critical angle, this one is critical angle, depends on the refractive index of the medium. Critical angle depends on the refractive index of the medium. So this was the statement we are going to use to answer the question. So now I get that what is the message from the question? Light transparent medium of n for refracting falls on the surface separating the medium of an air. So this is what that medium. So this is air medium. Okay, this one is we don't worry about it. So this one is just air medium. This is what a transparent medium. Okay, transparent medium, transparent. Okay, wait, I just want to clear transparent medium. Now, okay, transparent medium. So this is what the refracting index, which is the refracting index? It may be for the case of total internal reflection. That's what the question. Okay, air medium falls under 45 degree, ray goes to total internal reflection. What is n? N, this one. Okay, so angle of incidence they are giving 45 degree. Total internal reflection in the case, what is n? So this was the diagram representation. So this was the medium separation area. This one is air medium. This one is transparent medium. The light ray from the transparent medium falls in the on a surface separating the medium from air at an angle degree 45 degree. Okay, 45 degree. So the ray goes to total internal reflection. What is the n? Okay, so already we seeing the page number 19. 1 by n is equal to sin I c. Okay, so we needed what is n. So we don't worry about this. This is all the I write from the page number 19. So that's what the simple sin I is equal to 1 by n, sin is equal to sin inverse of 1 by n. So sin I is equal to greater than of 1 by n. This in this case. So n is greater than of sin I. N is greater. N should be maybe equal or greater than. So because the condition we know that the page number 19 water medium, in case of that water medium is having that much higher refractive index than air medium. So n2 divided by n1, right? Sin I by sin I equal to so see n2 divided by n1. That is why I am using that term. So it should be that n1 is greater than n2. So directly we are giving that medium of refractive index here. So that is why we are commonly use n. So n should be greater than sin IC, sin I. So sin 45 degree. I means the incident angle 45 degree. Sin 45 degree is, so we know sin 45 degree is 1 by root 2. So 1 by root 2 means in the division it goes to that upper side. Okay, numerator. Right. So division, the denominator goes to the numerator. So n is greater than root 2. The value of root 2 is 1.44. So in the answer 1.25 and 1.33, 1.4 and 1.5. The condition is greater than of 1.44. So greater than of 1.44. The only one answer we have is 1.5. So the answer is D. Okay. Okay. So now fine. I hope you understand. Very easy as well. Thank you. Simple formula is there. N is equal to sin I. So instead of I, the value is 45 degree. Sin 45 degree. Sin 45 degree is 1 by root 2. Okay. So the denominator is going to numerator. Okay, so the fractions it may be multiply with the inverse. Okay, root 2. Root 2 value is 1.42. So nearest value and greater than is 1.5. So you can use this method also. This is very simple, I think. So for the explanation, detail of question and the background of the question only we are going to be seriously. So understand the question. So once we understand it, once we understand the concept, you can use the formula this also. Okay, thank you.